Hello everyone, in this video we will talk about relief cuts and darts. Today I will show you how to use Exact Flat's shortest path cutter, the plane cutter, and the curve cutter, and I will also show you how to use some of Rhino's cutting tools to create cuts in your mesh before flattening. We've already flattened our part here. We've got our 3D model on the right, and we've got our 2D pattern on the left. To begin, I'll show you the shortest path cutter. We can start the shortest path cutter using this icon here in the Exact Flat toolbar, or we can type the EF-cut command. The shortest path cutter works by allowing you to select a start and stop point for your cut, and Exact Flat will automatically determine the shortest path along existing triangle edges to form that cut. You don't have any control over where that path goes. However, instead of creating one cut from the start to the end, what we can do is we can create multiple cuts across the path to create our cut profile. When we're done with our cut, or if we don't want to cut, we can always use the undo function to undo the cut, or we can use the Exact Flat delete cut command to remove the cut. We can create cuts in both the 2D pattern and the 3D model using the shortest path cutter, or even the curve cutter or the plane cutter. You don't have to use only the 2D pattern, you don't have to use only the 3D model. You can create cuts on both. And in the case of the shortest path cutter, there's really no difference between the two. It may be easier to see your cut path on the 3D model, but the cuts are created exactly the same. Next, we'll have a look at the plane cutter, and this works by creating a plane across the surface of your pattern. We'll start by turning on the plane cutter by clicking the icon here, and this command works differently when used on the 2D pattern versus the 3D model. When used on the 2D pattern, we select a starting location, and then we choose a reference vertex for the end of the cut. And when we choose a second point, it creates a cut along that line and allows us to separate the pieces. When used on the 3D model, there is a third step required. First, we choose our start vertex. Next, we choose our end vertex, and then we choose a third reference point on the surface of the model. And depending on where the third reference point is, this changes the angle of the cut that's going to be created, and thus changes the geometry of the cut. The plane cutter works the same on both the 3D model and the 2D pattern. However, the cuts that are produced are a little different because with the 3D model we're creating cut in 3D. With the 2D pattern we're creating cut in 2D. To show this, I'm going to turn off our strain highlight and edge highlight, and I'm going to make sure that our vertex snap is turned off. Next, I'm going to use the Exact Flat curve command to simply create a curve on the 2D pattern. I will now use the Exact Flat curve cutter to create a cut along the profile of this curve. We turn on the curve cutter by selecting the curve cutter icon in the Exact Flat toolbar. We select the model or pattern piece to cut. In this case, we're going to cut a pattern piece. And then we select a curve on or near the surface of the pattern. The dialog we're seeing represents how many points are going to be in the polyline that's created from the curve. With the curve cutter, when we choose a spline curve or NURBS curve, the curve will first be tessellated into a polyline, and then the cut will be created from all the vertices of the polyline. This dialog allows us to refine the polyline that's created to give us more or less polygons. When we click OK, Exact Flat will create a cut along the profile of that curve. We can do the same on the 3D model. We can use a couple different commands to create our curves on the 3D model. The easiest one to use is probably the Rhino sketch command. This allows us to create a sketch on the surface of the mesh. Just by clicking and holding our mesh, we can draw a curve on the surface of the mesh. We can now use this curve to create a cut on the 3D model piece. Again, we'll start the curve cutter. We're going to select the model piece to create the cut on, and then we'll select the actual cut. Because this is a spline or NURBS-based curve, we're asked to choose the curve fit tolerance to determine how many vertices will be created. And when we click OK, ExactFlat is going to cut along the profile of that curve. Other methods to create curves on the surface are to either pull a curve onto the surface or to project a curve onto the surface. Lastly, I'm going to show you how to create cuts in your 3D model before flattening. To do this, I'm going to clean the document and undo the effects of the flattener, and we will maximize a perspective viewport. This method will use both the projection and the pull commands from Rhino, both of which can also be used in conjunction with the curve cutter to create curves on the 3D model for cutting. The benefit of doing this cutting operation before flattening is you can then use the adaptive or uniform remesher to retessellate your mesh with those cuts taken into consideration. To begin, we're going to angle our camera into a position so we're looking at the mesh where we want to create the cut. So for this one, I'm going to create a V-shaped cut right along the surface here. So what's going to happen is if I create a curve in our viewport, Rhino is going to project it along the axis of the viewing or the construction plane, which is not doesn't follow the direction that we're looking at. So the easiest way to solve this is we're going to create a new construction plane. We're going to create a new grid that is perfectly parallel or perpendicular to the view right now. To do this, we're going to use the Rhino C plane command, and we're just going to use the view option. Now we've relocated the construction plane so it is perfectly perpendicular to our view. Now we can use the Rhino line command or the Rhino lines command or curve command to create a curve. And what we're going to do is we're going to create a curve here, and instead of this I'm going to use the polyline command and create a curve here and a curve there. So right now, this curve does not actually intersect the mesh at all. In fact, we can rotate our camera around and we can see that the curve doesn't even touch the mesh. However, it is on the construction plane, so any kind of curves that are created, they're always directly on the construction plane, and that's why we created a new construction plane that's perfectly parallel to where we wanted the cut to be. So now what we can do is we can use the Rhino project command, and we can project this curve onto this mesh here. So we'll use the project command, we're going to select our curve here, press enter, and we're going to project onto this mesh. And what Rhino is going to do is it's going to project this curve along the viewing direction of the construction plane directly onto the mesh. And now if we rotate, we can see the projection of that curve onto this mesh. So this can be used, the same method can be used to create curves for use with the ExactFlat curve cutter, or in this case what we're going to do is we're just going to use simple Rhino commands. We're going to split this mesh along the curve. So to do this, we're going to use the split mesh command, the mesh split command. We're going to split this mesh, and we're going to split it with this curve. And in this case, unfortunately, the split mesh command failed. So what we can also do is we can use the split mesh with curve command. We're going to split this mesh, and we're going to split it with this curve. The command doesn't always work the way we'd like it to. In this case, it did create new splits along here. However, it failed to fully separate it. So what we're going to try to do is we're going to try ungrouping, see if this works, and yes, we were able to ungroup it, and now we can separate this out, and we'll flatten this with the V-shaped notch already in the pattern piece. We can also rerun the adaptive remesher to create a new topology to remove these thin triangles and smaller triangles. Another option is to simply not project the curve at all. And in this case, what we can do is we can just use the mesh split command, and the mesh split command will automatically project this curve onto the mesh for us. So we're going to split this mesh using this curve. In this case, the curve was projected onto the mesh, saving us a step. So again, we've selected two meshes indicating they're grouped together, so we're going to ungroup these two, and now we can separate this piece out.